Now it's time for an exercise. Download the attached starter notebook and try to solve it by yourself. I have also attached the solutions notebook. If you get stuck, check just that part of the solution from the solutions notebook or from this video and continue. At the end, come here and see my solution. Now let's pause the video and begin. Hello, I hope you did well on the exercise. If you are done, let's solve it together. We will define two variables called a and b, and they will have integer values 6 and 2. Let's do this. A is equal to 6 and b is equal to 2, and we will run this cell. Okay, after that we will add them together and assign the result to a variable called sum. Sum is equal to a plus b, and we will call sum in here and run this cell, and we will have 8 6 plus 2. By the way, you need to run this cell to get this value, because after that your a and b variables will have the values you have assigned to them. Okay, now we are going to subtract b from a and assign the result to a variable called difference. Let's do this. Difference is equal to a minus b, and we will call difference in here, and if I run the cell we will have 4. Now we will multiply them and assign the result to a variable called product. Product is equal to a times b, and called product. Run this, and there is something wrong in here. We forgot to put equal sign. Okay, it's 12. Divide a with b and assign the result to a variable called division. Division is equal to a divided by b. Run this, we will get 3, and this is a float. Do the same thing with floor division. Let's do this. Floor is equal to a floor b. Floor is equal to 3, but this time it is an integer. Calculate a to the bit power, a power of b. And if I run this, we will get the square of 6, which is 36. Okay. Now it says save your first name, age, job, and marriage status into accurate variables. Let's do this. Name is equal to John. Okay. Age is equal to 30. Job, engineer. And let's create a variable like this is married. And this will be a boolean, and it is false. Okay, let's run this. We have defined one string, one integer, one string again, and a boolean. Okay, we will put the variables in a list called me. Me is equal to a list, and we will put directly the variables that we have defined: name, age, job, and is married. And run this. Add your last name to your first name. Let's do this. Name is equal to name plus, let's say, Wick. And if I call name in here, we will have John Wick. And you can put a blank line in here to separate those. Let's run this one more time, and we got something wrong in here. Why is that? Because we have defined the name in here, and after that we have added Wick to it, and we got this. After that we have changed something and added one more thing at the end, and this didn't take it from the beginning. It added this Wick at the end of the John Wick, which we have defined in here. Okay, to not face those issues, if you are going to change something, if you are going to repeat some operation like this, you need to run the cells from the beginning. Here I don't need to run from beginning, because we have just defined those variables in here. So I'm going to run this cell one more time, and also run this one. And if you run this again, this time you will get the correct version of your name. Okay. Now let's increase your age by 2. Okay, age is equal to age plus 2. And actually we can do it like this with the plus equals operator, age plus equals 2, and now our age is equal to 32. Okay, let's do this, run this one more time and see the thing we have faced in here. Run this one more time, and if you run this again and again, sorry, run this again and again, as you see your age is increasing by 2 every time. And as I said, to correct this, to fix this, let's come in here and run this from the beginning. Okay, I will run this cell. After that, this list cell. Let's run this one more time, and if I run this again, we will get 32. Okay. Change your job to your dream job by assigning a new value. Job is equal to, let's say, teacher. Okay. Change your marriage status. Let's say is married is equal to not is married. This not will change a true to false and false to true. So if you don't know which value is this, you can change it by just calling not, and we could also change this to true directly, but let's put it like this: not is married. Okay, now let's put the variables in a list called new me and print the list. Okay, new me list is equal to name, age, job, and is married. Okay, now this new me list in a print function and run the cell. As you see, now we have John Wick, and name is age is increased by 2. We don't see teacher in here because I forgot to run the cell. If I run the cell one more time and this cell again, we will have teacher in here, and our marriage status is true. Okay, check if your age is higher than 18 and if you are married. Okay, how can we do this? Age is greater than 18, and since here it says and, we will use and keyword, and is married. We are writing this directly because this is a boolean. Let's run this, and it is true because both of the conditions are true in here. Let's check if your age is higher than 25 or if you are married. Let's check this also. Age is greater than 25 or is married. If I run this, we will get true because again both conditions are true in here. Here let's also check age is greater than 35 and is married. If I run this time we get false. This is showing the last item, by the way. This is not showing this, just showing the last item. Why did this give us false? Because our age is not greater than 35. Since, even if this is true, since we are using and in here, this will return false. Okay. Calculate your BMI, body mass index, both in metric units and imperial units. Find the formula from Google. Okay, let's open the formula. For the metric system, it is weight over height squared. Weight is in kilograms and height is in meters. And for the imperial system, it is weight over height squared times 703. And weight is in pounds and height is in inches. Okay, let's open the notebook again and let me copy and paste something in here. Okay, let's calculate BMI values for a person whose weight and height values are like this. Let's start with the metric BMI. Metric BMI is equal to 78. This is the weight in kilograms over 1.78 squared. Okay, let's call it to see what we get. We get this float value. Okay, now let's calculate it for the imperial values. Imperial BMI is equal to what are we going to do? It was 703 times, and let's open parentheses, 1.1 171 time 0.96 divided by 778 square. Okay, imperial BMI, let's call this. As you see, they are very close to each other, but because of the convergence, they are not exactly the same, and they are floats values, of course. Now let's check if the two calculated BMI values are the same. Let's do this. Metric BMI equal imperial BMI, and if I run this, we will get false, because even if they are very close to each other, the values after 61 are not the same. Okay, now we will convert BMI values to integers and we will check them again. Let's say metric BMI is equal to, in integer function, we'll put the same thing in it, metric BMI, and we will do the same for the imperial one. Imperial BMI is equal to int imperial BMI. Okay, after that, let's see if they are equal now. Okay, if I run this one more time, as you see, we got true. And if I want to see their values, metric BMI and imperial BMI, if I run this one more time, as you see, we got 24 and 24. Okay, this was all for this exercise.